Let's say we have some boat in a river, and there's two people pulling on this boat on both sides of the stream, and they're both 35 degrees off the horizontal. And they're both pulling with a force of 75 pounds. So let's call this one on top, let's call that vector A, and we'll call this one down here vector B. Like I said, they're both 75 pounds. So they're both basically the exact same, just sort of going in, not really an opposite direction, but kind of contradicting directions. So my question to you, what is the final force? What is the direction and the magnitude of the final force of these two combining? Well, if I were to make a guesstimate, I would say that vector A, which is, what, 35 degrees off the horizontal, and vector B, which is also 35 degrees off the horizontal. Well, since their magnitudes are equal and their angles are equal off the same axis, the y components of each should cancel out and it should go straight to the right. The x components should just add up and that'll be the total magnitude. And that's my guesstimate for this. Let's see if we're right. So let's start with vector A, which is, again, still 75 pounds. Well, vector A has an x component and a y component. So we got our y component here. And it goes a little bit higher, so we'll redraw it, but we'll call it A of x, or I'm sorry, this is A of y. And then it's got its little x component here, which goes as far as the arrow itself does. So this is A of x. And of course, the whole vector is 35 degrees off the horizontal. So let's start calculating the x and y components. Well, to do that, we need to look at this as a triangle. So I'm actually going to redraw vector y over here as a dotted line. And not vector y, component y of vector A, so A of y. But now if we look at it, it's clearly a triangle. So to find A of y, well, that's the opposite. So A of y, let's go ahead and write it out. We don't know what that is, but to find it, well, what are we going to do? We're going to say, well, it's opposite. We know the hypotenuse, so that's sine. So the sine of our angle, 35, well, that's equal to, well, it's opposite of our hypotenuse. Well, the opposite is A of y, and the hypotenuse is 75. And to figure out whether or not whether I multiply or divide, instead of doing the algebra of it, I just put it over 1 and just make it a proportion problem, and I cross multiply and divide. We'll do sine of 35 times 75 divided by 1, so we'll type that in our calculator. So we'll do, on top, we've got this 75 times the sine of 35, and on bottom we cross multiply and divide by 1. Well, as we know, that doesn't really change anything, so we really didn't need the over 1, but I find it helps me figure out if I should be multiplying or dividing and which number goes on top. So we get 43. So A of y, or we'll rewrite it, A of y equals positive 43. When I say positive, because it's going up. The y component is obviously going up in vector A. So I'll go ahead and box that answer right there. The component of A of y, or the component of y of vector A. And to solve for A of x, we'll do something very similar. A of x equals question mark. Well, then we can rewrite it as, well, this is adjacent. It's adjacent to our angle, so it's the cosine of 35 equals A of x divided by 75. And again, instead of trying to do all the algebra and try to figure out what number goes on top or guessing, I'm just going to make it a cross multiply and divide. It's cosine of 35 times 75 divided by 1. So we can rewrite this as, well, we'll say A of x equals, well, whatever that is when we type it in our calculator. So we pull up our handy dandy calculator and we say, well, the cosine, or 75 times the cosine of 35, and I don't have to divide by 1 since I know that's what's going to be the number on bottom. I know that doesn't change it. And we get, what, 61.4? And it's positive 61.4. And so now we know the x and y components of vector A. But what about vector B? So we draw vector B out, same way as we drew it before, same way as we just drew vector A. And that equals 75 pounds as well. It hasn't stopped being 75 pounds. And we'll solve for these values the exact same way. We'll solve for, well, this would be b of y since it's going up and down. And we'll solve for b of x, the x component. And this is b of x because it's going left and right. The exact same way as we solve for this. And of course, it's still 35 degrees off the horizontal. Well, first things first, I'm going to go ahead and redraw b of y over here so it looks like a triangle. I'm just sort of translating this vector, or this x, or this y component of the vector anyway. So we do the exact same thing. We say b of y equals what? Well, b of y is the opposite of our angle, so it's still the sine of 35 equals what? B of y over 75. And I want to stop right here before we go any further. I want to point out that y components are not always sine and x components are not always cosine. It just worked out that way this time. But you got to look at your triangle to know if it's going to be sine or cosine. Well, if you look, we're just going to put this over 1 again. We can say 75 times the sine of 35 is b of y. So it hasn't changed. We're going to type it in the exact same way in our calculator. In reality, we really don't even have to type it in because it's going to be the exact same question as before. It's going to be the sine of 35 times 75. And I got to make sure I put my parentheses there. So it's not the sine of 35, 75, but we type it in and we get the exact same numbers before. We get b of y equals 43. And it's negative 43 because it's going in the negative direction. It's going downward. So now we're 3/4 of the way there. We're just going to find that last component, which is just b of x. Well, b of x is going to be the exact same thing as before. To find it, what we're going to do is we're going to say, well, it's adjacent. We're looking for the adjacent. We have the hypotenuse, so that's cosine. It's still cosine, just like before. Cosine of our angle, which is still 35 degrees, which equals b of x divided by our hypotenuse, because b of x is our adjacent, divided by our hypotenuse, which is still a vector force of 75 pounds. And again, there's no reason to retype this in. 75 times the cosine of 35 is still 61 point. So we have the exact same answer as before. We can write this as b of x equals 61.4 pounds in the x direction. And it's important to note, since this is going to the right and it's an x component, it is positive. So now we have all 4 of our components, the x and y component of both vectors. So let's see what direction it's going. Well, let's look at the y direction first. So the sum of all forces in the y direction. Well, that's going to be what? It's going to be positive 43 minus another 43, or plus negative 43. Well, they cancel out. Sum of all forces in the y direction is 0, so it's going to go straight to the right, which is what we guesstimated earlier. So what about the sum of all forces in the x direction? Well, that's going to be positive 61.4 plus another 61.4, which is what, 122.8? So with this in mind, our guesstimate was correct, and that kind of makes sense that it would just go to the right. So if I were to redraw this boat down here, I could redraw our final force with a magnitude of 122.8 pounds of force straight to the right with no y components, or we could write this as 0 degrees off the positive x-axis. And that would be the magnitude and direction of our resultant force, or final